new topic, that is your battery. So basically, battery is of two types. We have two types of battery, as I already told you in the previous class. The one which cannot be recharged or reused again, or you can say recharged and can be reused. Like the battery we used in our phone, laptops, and all that is your we can reuse. So this type of battery is called secondary battery or secondary cell, we can say secondary cell or secondary battery. And the battery or the cell which cannot be reused again is called primary battery. Are you getting my point?
Yes, sir.
So you know what you need to know. There are some examples of primary and secondary battery or cell, and you need to take care of that. Like if it is a battery, there will be two electrode, anode and cathode. And what is the reaction at anode and what is the reaction at cathode? That you need to remember. Okay, so I'm gonna give example of this. The first example of primary cell is Leclanche cell. The second example in our syllabus is your mercury cell. Mercury cell. And if you are going for secondary cell, we have lead storage cell. Lead storage cell. The second one is nickel cadmium cell. And the third one is your fuel cell. So basically, the example of cells that I have written on the right hand side is secondary cell. That means you can reuse it. But on the left hand side, two examples are there, like Lanke cell and mercury cell, that cannot be reused. So please do write it one by one. I'm going to explain all this. Let me know when you are done with this.
So what's the second one in the secondary cell? NIC.
Yeah, nickel cadmium.
Okay, sir.
NICD.
Done, sir.
So write a topic. We are going to start from this primary cell, and the first one is Lancashire. Now see, what is this Lancashire cell? So I'm gonna uh, draw this. Basically, it's a copy. You can see it is a Lancashire cell in which you can see that this part, the rounded part, circular part, cylindrical, you can say, is your carbon rod and it is your cathode. As I told you, in these cells, there will be electrode, cathode, or anode. And this part, basically, this part is your zinc cup or made up of zinc, which is anode. Are you getting my point? This is your anode, this part, and this part is your cathode. And this part is filled with paste of, that means molten state of MnO2 plus carbon black plus NH4 Cl paste. Are you getting my point? Yes or no?
Yes, sir.
Now see what will happen at anode. You know that at anode oxidation takes place. So what is present at anode? Zinc. So zinc will oxidized into Zn plus 2. What is oxidation? Loss of electron. And you can see at cathode reduction takes place. So see at cathode what will happen? This is very important. At cathode, this paste will come into play. That means MnO2 will be reacting with zinc. Since zinc is giving electron, so one of them will gain electron, and there will be NH4 positive. How does this NH4 positive come? So you can see ammonium chloride is there, and since it is paste, so it will be dissociated into ions NH4 plus and Cl minus. Now see what will happen here. It will be reduced this MnO2. I'll show you how it is reduced. MnOOH. This is what it will become. Plus zinc is already reduced, so this will form a complex compound with ammonia, ZnNH3 whole 4 raised to the power plus 2 plus 2. Just wait a minute. I wrote the whole reaction, complete cell reaction. Wait a minute, just wait a minute. See what will happen. What I told you is that this cathode is made up of carbon rod, and this anode is made up of zinc, and you know that at anode oxidation takes place. So oxidation takes place, Zn converted itself into Zn plus 2. Now you can see at cathode this paste, and it will react with NH4 positive, and it will convert itself into MnOOH plus NH3 gas. NH3 gas. Now you can see that this is going from 0 to plus 2, which is oxidation. And here, if you are going to check the oxidation state, oxygen has -2 and 2 oxygen is there. So this manganese will have +4 oxidation state. But if you are going to check the oxidation state of this due to this oxygen, this will have -2, but OH is hydroxide ion, which is -1. So oxidation state of manganese will be +3. So you can see reduction took place here. So this is the reaction of Lac-Lanke cell at anode at cathode. And you should also remember the net cell reaction. Net, just wait a minute. Net cell reaction. Net cell reaction. What is net cell reaction? So basically this half cell reaction. What is half cell reaction? Oxidation reaction and reduction reaction. If you are going to add them, you will get redox reaction, which is net cell reaction. So what you need to do is very simple. If you know the reaction at cathode and anode, you just need to add the left to the left and right to the right. That means on the left hand side you can see zinc is there, and on the left hand side at cathode, just wait a minute, it's hanging, MnO2 is there. Just wait a minute. MnO2 plus NH4 positive on the left, and you need to add add on the right hand side. Also, there is one important point. This oxidation state decreases, that means reduction takes place. So you need to add two electron as well. So that electron. And on the left hand side, two electron is also there. Now what you need to do, add right to the right. That means Zn plus 2 plus, just write with me. It's little bit slow right now. I don't know why. Now this 2 and 2 electron will be cancelled. 2 electron is also on the right hand side, you can see, with zinc Zn plus 2. So these both will be cancelled. And again, you need to write the left hand side and right hand side. So the final reaction I'm gonna write is this. On the left hand side, zinc will be there only. Then MnO2 is there. Then NH4 positive is there. We cancel two electron, and then on the right hand side, Zn plus 2 is there. Then wait a minute, Zn plus 2. Okay. Not a problem. This first I'm gonna write MnOOH, and then this Zn plus 2 and NH3 react together to form a complex, that is ZnNH3 whole 4 raised to the power plus 2. Please do write it. This is your net cell reaction. Let me know when you are done with this. Also, please do write it in Lac cell that voltage approximately 1.5. Sometimes it has been directly asked.
Every time it will be 1.5 only.
Yeah, of this cell
Okay, sir.
for Lac. Are you done with this?
1 minute.
Okay.
Done, sir.
Okay. Now the next primary cell. So right topic, mercury cell. And voltage here is voltage approximately 1.35 volt. 1.35 volt. I'm just gonna take a diagram of this. It's something like this. Yeah. So there is also cathode and anode, you can see. Just wait a minute. Yeah. Now I'm gonna write the reaction at cathode and anode. Mercury cell is also represented at Hg cell. Mercury Hg. Now, first of all, what is this anode made up of? So this anode is made up of zinc hydroxide, zinc amalgam, sorry, zinc amalgam, ZnHg, and cathode is made up of, you can see mercury oxide, monoxide plus carbon. And electrolyte, the paste that we use here is basically zinc oxide, ZnO, plus potassium hydroxide, KOH. Zinc oxide plus potassium hydroxide, KOH. Now I'm gonna write the reaction. At anode, you know that oxidation will take place. So at anode, see what will happen. This ZNO combine with this hydroxide, that means base, to lose electron. So this will be like ZNO plus 2 electron plus H2O. So basically this hydroxide will lose electron, and at cathode, see what will happen. This HGO react with electron and water is also there in the solution. So it reduces itself. HGO converted itself into Hg, and this will be 2OH minus. Is that clear?
Yes, sir.
So this is half cell reaction, oxidation half cell reaction. This is reduction half cell reaction. I will write the net cell reaction as well. First, you are going to write this. Oh, wait a minute. This is your ZnHg. ZnHg. Zinc amalgam is there now at anode. React with this to form this.
Sir, what does amalgam mean? I don't.
Amalgam is what we alloy
Oh, okay.
mercury. So you know solution. What is solution, right? When you are going to mix. So zinc amalgam. Amalgam generally represent mercury when it is mixed with mercury. Okay.
Okay, sir.
This is GG.
Done, sir.
Can you write the net cell reaction? What you need to do, just add left uh, this two half cell reaction. So if I'm gonna write net cell reaction, so what you need to do, add this and this. Like the electron are equal on left hand side and right hand side, so they will be cancelled, yes or no?
Yes, sir.
And 2H minus is also there, and you can see HGO, then 2 electron is there, then H2O is there. Now what you need to do, you can see on the right hand side ZNO, 2 electron plus H2O plus mercury Hg, and then 2H minus. Now this is not the net cell reaction. First you need to eliminate something from this. 2OH minus and 2OH minus will be cancelled, yes or no?
Okay, yes.
2 electron, 2 electron will be cancelled. H2 and H2 will be cancelled. So what will be the net cell reaction? You can see ZnHg plus HgO will combine to give you ZnO plus Hg. This is your net cell reaction. So please do write it. Let me know when you are done with this.
Done, sir.
Very good. So this is your net cell reaction. Always remember that. Now the next is your secondary batteries. Secondary batteries. Now in secondary batteries, we took the first example as the first example was about lead storage battery, right? Lead storage battery. So I'm gonna just copy paste the diagram. Here it is. So this is the percent of lead storage battery, and this is from your NCRT. See, there is an also said that in the compartments, 38% sulfuric acid solution is okay. Now positive plates, that means basically anode, grids filled with PbO2, and a spongy lead, the negative plates. Now again, same thing is gonna happen. First of all, cathode, basically cathode, you can see positive plate is made up of PbO2, and a spongy lead, that means lead, Pb. So you can see the negative plate, which is anode, the negative plate. I think I told you in the earlier, that was wrong. You can see positive cathode, that is made up of PbO2, and negative anode, that is made up of lead. Are you getting my point? Yes or no?
Yes, sir.
Now see, again the same story will repeat at anode. At anode, what will happen? Oxidation will take place. How? You can see at anode Pb is there. At anode, I told you negative plate, that is made up of Pb. That is gonna react with, this compartment is filled of H2SO4. That means SO4 minus 2. So what will happen? This Pb will lose 2 electron to convert itself into Pb plus 2, and then react with SO4 minus 2 to form PbSO4, and it will lose 2 electron to oxidize itself. You can see like this. Now at cathode, what will happen? At cathode, at cathode, it is made up of PbO2, and SO4 minus 2 is also there. SO4 minus 2 is also there. And you know that this is, since acid, so acid will also be there, 4H plus. I'm gonna take to balance it. And since cathode, at anode, it lost electron. Okay, you can see this lost electron. So someone will get this again, this electron. So this 2 electron will come here and it will gained by this, and it will convert itself into PbSO4 plus 2H2O. It will reduce itself. Now net cell reaction. Net cell reaction. I'm not gonna write two reaction for net cell reaction. I'm gonna directly show you how you are going to write it. Can you see this 2 electron here and 2 electron here? This will be cancelled. Yes or no? This will be cancelled. Now you
Yes.
can see on the left hand side Pb, and Pb is nothing on the right hand side. So Pb will be as it is. Now PbO2 is also alone on the left hand side. So it will be PbO2, right? And here you can see SO4 minus 2, SO4 minus 2. It will combine to form 2SO4 minus 2. Yes or no?
Yes, sir.
Now you know that SO4 minus 2 combined with the 2H plus to give you H2SO4. Yes or no? So when you have 2SO4 minus 2 and 4H plus, so it will give you 2H2SO4. Are you getting my point? Yes or no? SO4 minus 2 combined with 2H plus to give you H2SO4. So 2SO4 combined with 4H plus to give you 2H2SO4. Yes or no?
Yes, sir.
Now on the right hand side, come on the right hand side. PbSO4 combined to give you 2 PbSO4, 2 moles of PbSO4, and then 2H2O is also there, 2H2O. So this is the net cell reaction for lead storage battery. Now, since first write it, then I'll again explain. Let me know when you are done with this.
Done, sir.
Very good. Now see, since this battery is chargeable, you can charge it. So the reaction that we have written, this is your discharging reaction, discharging when you are using it. So this is your discharging reaction. Now, what if you want to write the charging reaction? You just need to reverse the equation. When you are going to put this on charging, the reaction will be reversed. Are you getting my point?
Yes, sir.
The reaction will be reversed and then it is charging. So please do write it. This reaction is for discharging. The reaction which I am writing is for charging. Let me know when you are done with this.
Done, sir.
Very good. Now the next is your nickel cadmium. Next is your nickel cadmium. Nickel cadmium cell. And here the voltage is approximately voltage equals to 1.2 to 1.4 volt. Just wait a minute. Now you can see this is the voltage range. Now again I'm gonna write anode here is made up of cadmium CD and cathode here is made up of nickel hydroxide. Here sodium hydroxide.
Sir, your voice
Now,
is breaking.
is my voice breaking?
Yes, sir.
Okay, just wait a minute. Am I audible clearly?
Yes, sir. Now you're
No. Again, let me know when my voice is lagging or breaking. At
okay.
anode, you know that at anode oxidation will take place. So at anode C is there and electrolyte OH minus. So they will react with each other plus, and then you can see at cathode at cathode. Am I audible clearly?
Yes, sir. Little bit.
Yes. Am I audible clearly?
Yes, sir. Now you're clear.
Okay. Now you can see at cathode reduction takes place. So 2NiOH plus 2H2O gains 2 electron to give you 2NiOH whole twice plus 2OH minus. Please do write this anode and cathode reaction. And if you want to write net cell reaction or discharging, So you need to just add as it is, discharging. Can you write the reaction for discharging?
Yes, sir.
Okay, please do write it.
It's the same method, right? After taking it
Yeah,
in one line, cancel out the common ones.
yeah, you can see discharging is same. This will left will be added in left. You can see this will be Cd plus 2OH minus plus 2NiOH and 2H2O is also there. Electron will be cancelled and here it will be CdOH whole twice plus 2NiOH whole twice plus 2OH minus. And 2OH minus 2OH minus will be cancelled, right?
Yes, sir.
These both will be cancelled. So only this part is for discharging. You can write the reaction for charging, right? Yes or no?
Uh, so different charging, I didn't get it. Like difference between discharging and charging.
Mm,
The same
is what?
equation,
This
right?
reaction, if you are going to add, you will get the net cell reactions. Yes or no? Net cell
Mm,
reaction. When
yes, sir.
you are using your phone and if this battery is in your phone, then the reaction is this. When you are using this, the reaction is this. That means this is discharging. If you are using your phone or laptop, it is discharging or charging.
Discharging, yes.
Discharging. So if you are going to put it on charging, the reaction will be reversed.
Yes, sir.
Reversed. So please do write the reaction for charging as well.
Okay, sir. Bye.
Let me know when you are done with this.
So will it be like CdOH2 plus 2NiOH2?
Yes, and on the right hand side, it will be Cd plus 2NiOH plus H2O, right?
Yes, sir.
For charging, it will be the, you just need to do the reverse, nothing else. And this part will be on the right hand side, right?
Yes, sir.
Now I'm going for this fuel cell. So this is your fuel cell in which you can easily see that anode, cathode, and there is water H2 on the anode side and O2 on the cathode side. So at anode, what will happen? Oxidation will happen. This hydrogen will combine with OH minus, 2 moles of this to give you 4H2O plus 4 electron. Also, this is in this the electrolyte that is present is your basic, that is NaOH. Now at cathode you can see O2 react with 2H2O, gains 4 electron that is lost at anode and convert itself into OH minus. So you can also write the net cell reaction. You can write if you have got the half cell reaction, this and this. So you can easily write the net cell reaction. Please do write it.
Sir, there's 2H2O and 4H2O. Can I
Two
reduce
H
it?
reduce it matlab 2H2.
मतलब
Yeah, you can
from
see
4 to
it's
2.
basically yeah, it's basically the same like maths. If here it is 4 and here it is 2 and you are going to move it 4 minus 2 it will be and becomes 2 only,
Yeah, okay, sir, got it.
right?
Yes, yes.
So net cell reaction you can see first of all this 2 will be cancelled, this 2 will be cancelled, yes or no?
Yes, sir.
Now you can see 2H2 on the left hand side which combine with O2 on the left hand side, which will give 4H2O is here and 2H2O is here. When it will move towards right side, 2H2O will form only.
Okay, sir.
Please do write it.
Done, sir.
Very good. I'm gonna give you a very easy question.
So fuel cell won't have volt or anything.
Volt or what did you say?
I mean, approximate to value of it, fuel cell.
There is no H2O2 fuel cell. Please do this question. So it's approximately 1.3, 1.3 Mamuddin, are you able to see the question?
Yes, sir. The answer is D.
The answer is
D.
very good.
2 plus.
Very good. Yeah, yeah. This is the option.
The answer is D.
Answer is D. Very good. Very good. Uh, Mamuddin, due to power cut off in my area, my laptop is gonna discharge, so I have to cancel this class at this time. I will be taking an extra class for this half an hour. Okay. Do you have any?
Okay, sir.
Do you have doubts?
No, no doubt, sir.
Any doubt?
No, no doubt, sir.
Okay. This chapter is almost completed. Only corrosion part left that will be shown in the next class. And after this, which chapter we are going to do? Chemical kinetics. Which chapter is going on in your school?
Chemical kinetics done.
Okay. So, okay. Thank you so much for today. And thank you for the cooperation.
Okay, thank you, sir.
Thank you.